Inscribed angles. The vertex is on the edge of the circle. And then the angle extends outward. Does everyone see that? The rays go to the rays go to the circle, right? And inscribed angles can look really weird, like some of these, or they can look normal. Central angles always are in the center. The vertex is in the center of the circle. And this is important to know the difference, because right here pretty quick we're going to learn how to find the angle measure of them and the arc size, arc measure. Okay, questions on the difference between those two? Alright, let's do some math now. You guys ready? Okay, if I draw it, you guys draw it. Bill? So, if I have a circle, so I'm going to get these things right off your homework. If I have a circle, and if it has an angle like this, this is D, A, C, B, and E. And then it tells us this angle right here is 85 degrees. Alright, the things it tells us is the name of this circle is circle A. The diameter is BD. And angle BAC is 85 degrees. That's the information they give to us. Alright, now they want a bunch of different things, so we're going to go through every single thing that they want on their homework. So we're going to do 2 of these type of problems today, okay? 85. Alright, the first thing they want is they want an inscribed angle. Someone tell me an inscribed angle there. We just barely learned about them a tiny bit. Preston, tell me an inscribed angle. Perfect. The only inscribed angle is BDE. That's it. Now, Preston, now that you told me that, how do I know that's an inscribed angle? Good. So the point's on the edge and the rays go to the edge. So the rays of it go to the edge of the circle also. So BDE is the only inscribed angle. But look at this one. What about ACD? Yeah, well, it looks like it could be one, right? Look at this. So angle ACD. That's not an inscribed angle. Just someone tell me real quick. Why is this not an inscribed angle? Yeah, well, this thing doesn't continue through. If this thing continued through all the way out here, then it would be. But where it stops right there, it's not an inscribed angle. Okay, does that make sense? Alright, so just one inscribed angle. Okay, it says give a semicircle. What the crap? I bet it wants an arc, yeah. Okay, so give me a semicircle arc. Tell me one. BD is the diameter, right? BCD is the semicircle. Tell me another. What? BED is another. Those are your 2 semicircle arcs. Now, it only asks for one, so you only need one. But, yeah. Okay. Let's tell me a major arc. BCE, that is a major arc. Well, look, DCE is a major arc too, because D to C to here would be 180, so DCE would be a major arc. I said BCE. Is BCE a major arc? Yeah. It's huge, right? That's like 200 or 320 probably. B to C to E And there's a bunch, right? You could say E to D to B, right? Or E to B to C. E to D to C, I mean. So anything greater than 180, right? Anything bigger than half the circle. Okay, it doesn't ask for this, but I'm going to do it anyways. What about a minor arc? Tell me a minor arc. Yeah, BE, BC, anything less than half the circle, right? All right. Now to the math. That's just letters and English, right? A lot of letters. If they wanted to know what arc BC is, so I'm going to put it right here. They want to know what arc BC is. So they want to know what the measure of arc BC is. This is really easy, and I need everyone to, hopefully, I think everyone's listening pretty good. The central angle is the same as the arc it makes. So this angle right here, CAB, makes arc BC, right? Because if you think about this angle CBA, if you look at these last two letters, CAB, Judas, I wrote it wrong. CAB, C to A to B, that angle right there is a central angle. These last two letters is the arc. Does everyone see that? How this angle makes that arc? It's like a piece of pizza, right? The crust of the pizza is the arc. So this angle right here makes that arc. Well, if it's a central angle, then if this angle is 85, then the arc is also 85. No matter what. Whatever the central angle is the same as the arc. No matter what. So this angle right here, so if this is 85, we know that this is 95 right here, because 180 right here, right? So if this is another central angle, what would arc CD be? 95. We don't have to know that. It doesn't ask for it. But yeah. Okay? Does that make sense? Okay. What is the measure of arc BCD though? What is arc BCD? 180. How do you know it's 180? It's a semicircle. Okay? Yeah, if you add those two up, it gives you 180. Now listen. Now they don't ask for this, but I'm going to do it anyway because you're going to have a problem where it does. Inscribed angles are different. Central angles are the same. Inscribed angles are similar. What I mean by similar is they have a relationship. So let's say that arc BE was 40. An inscribed angle is half of the arc. So this angle all the way down here would be 20. Pretty cool, right? Yeah, cool. Cool. Okay, so an inscribed angle is half of the arc. Because this arc, I told you this arc, I just made it up, said this was 40. So the angle would be 20. Okay, so an inscribed angle is half of the arc. Central angle, the same as the arc. All right, let's do another. Can you guys see through that? No, it's kind of. I just want to do the back side so I don't use as much. All right, so here we go. Anybody getting good at drawing circles yet? You think I'd be better at it, having drawn them my entire life. A few. So this one's going to look like this. With another, it almost looks like the last one, right? Close. Okay, so this is S, R, P, Q, T. All right, they say that QS is the diameter, so everyone just remember that. Well, you can tell it's a diameter, right? If a line goes through the center and it's a straight line, it's a diameter, right? Okay. They tell us that this arc right here is 130 degrees. QR is 130 degrees. So what would the measure of this angle right here be? 130. Central angle is the same as the arc. Okay, the last thing they ask for, okay, this is good. So the next thing they ask for is arc QTR. I need someone to raise their hand and give me an idea. Now look at this. Arc QTR is this all the way around to there, right? Q to T to R. Travis? And you, yeah, easy, right? Does everyone see that? So there's a couple different ways you can do it. Hopefully, the cool thing about geometry, or also one of the worst things about geometry, is there's multiple ways to solve stuff. That's the easiest. He said, well, there's three. It's asking for the remainder of the circle. So this would, we know that this entire arc would have to be 230 degrees, right? Q to T to R, because we already know this is 130. The rest of the circle has to be 360. Now there's another way you could go about it. Well, I know this is a diameter, so if this is 130, that has to be 50, right? And then 50 plus 180 is 230. Because we know this has to be 180, right? Because that's 180, because this is a diameter. And I'm not going to make you list circles anymore. What about if I asked you to give me a, what's a central angle here? Central. Tell me a central angle. Preston, go. RPQ. Remember, P is the center, so it has to go from the edge to the center to the edge. What's another central angle? RPS would be another central angle. Tell me an inscribed angle. QST. Good. Tell me another inscribed angle. There's another one on there. QSR. Everyone see that? Okay. I want to go on arc length. Should we do another one of those? Okay, we need to talk about the difference now between inscribed and central. We're not on, we got to still cover arc length. Okay. So if I have an inscribed angle like that, and let's say this is the center of the circle, and then it also ends here. So we'll call this A, B, C, D. Okay. If I'm told that this angle right here is 60, what would the measure of this arc be? 60. If the central angle is 60, the arc it makes is 60. Now look though, what would be the measure of this inscribed angle? Half of it. 30. The inscribed angle is half of the arc. Okay? Or the arc is double the inscribed angle. Alright, questions for me so far? I know it's kind of can be a lot. This is new stuff. Okay. Alright, we're there.
So why is the 30 degrees, why is the 30 opposite?
This isn't inscribed, right? Yep. Inscribed start down here on the edge of the circle. Okay. Alright, we got to talk about arc length. So that's all about arc measure. Okay, now we're moving on to arc length. Like I told you yesterday at the very end of class, arc length is different than arc measure. So arc measure, here we go. You want to know what actually? So inside of your journal, you guys wrote down a formula for arc measure. Tell me the formula. I mean arc length. Tell me the formula. Not negative L, it's just L.
Oh, okay. L.
This is the formula.
Isn't it K?
No, it's L. There's no K. That's pi. I'm glad you're making up stuff, though. It's good. Means you're a math guy now. Now you're making up crap. Okay? So, this is the formula to be able to find L is arc length, X is the measure of the angle, R is the radius. Okay? And usually they want it in terms of pi. So I'm just you're only going to have one of these on your homework today. Okay? Because believe it or not, they don't want you to times pi by anything. They want pi a part of the answer. just the symbol pi. So, if they give us a circle, here, and there's the center, and they say that here's your angle, and they say this angle is 170 degrees. All right, these problems get a little bit weird. The reason being is because they say this is WX. They may say two things. They may say find the minor arc, find the length of the minor arc, or they'll find the length of the major arc. Now there is two different arcs here. What's the measure of, so this would be considered the minor arc, right? So we know the angle measure for the minor arc, right? It's 170. If it said find the length of the major arc would be that. So yeah, this would be 190, right? So this would be 190 over here. If it said find the length of the major arc, you would be looking at this. Now this one says find the length of the minor arc. So we're looking for this, which has this angle, right? Now this can be kind of tricky if it asks for a major arc, because a lot of people don't look at this as an angle out here. That is an angle right here. Is an angle. It's just you've never seen an angle greater than 180 before. Never till today. This is day number 1. Right? You can have angles greater than, you just can't have angles greater than 360 degrees. You can have an angle that's 351 degrees and it looks like this, but we're not talking about that. We're talking about that part of it, right? So angles can go both ways. It just varies based upon if it's asking for a minor or a major. Major's greater than 180, minor's less than 180. Okay. This one says find the length of minor arc WX. So we're looking at this angle. That's the angle we're going to plug into X. So here's our formula. L equals 170 over 36 times 2 pi, and the radius we'll say is 3. Okay, they'll give you a radius. So the radius is 3. Remember, if it asks for a major arc, what number would we plug right here?
190.
The 190. If it asks for a major arc, you'd plug the greater than 180 part of it. Okay. Remember, they want pi a part of our answer, so I'm going to teach you how to do this. Very first thing I'm going to do is I'm going to get rid of the zeros, if I can, just to make the problem a little easier to work with. And then I'm going to multiply those two things together like that. 2 times 3, which makes 6. Then I'm going to go 17 times 6, which is 102. And I'm going to get 102 over 36 pi. So 17 times 6, which is just 102. And then all I'm going to do is I'm going to just reduce this fraction. Okay? So 2 goes into it, and then 3 goes into it.
So did you do 17 times 6?
Yep, 17 times 6 gives you 102. And then pi stays out here. Someone reduce that for me. Go 102 divided by 36, and then hit math, enter, enter. 17.6. Someone do 102 divided by 36. 17.6. Then hit math, enter, enter. Because we need fractions. It's not going to take a decimal. So 17.6 pi. And that would be how you're going to write your answer. It might even ask you to put like feet. Probably. If it was in feet, you'd put feet. If it's inches, you'd put inches. Hey, I know this is a lot. And it's all new, right? This is all new stuff. So, let's do one more. We got time. I'm not going to give you a ton of homework, so let's do one more here. So let's say we had a circle, the center. They tell us this is 110. That's A, B, and the radius is 4. All right. It says find the length of the major arc, AB. So our formula, L equals x over 360 times 2 pi r. If it wants the major arc, what's our x? 250. Right? If it wants the major arc, if it asks for the minor arc, x would be 110, but it's asking for the major arc. So it wants the major arc AB, which is, we know that the measure of this, don't just put 250 as your answer. That's wrong, right? That's the measure. We're looking for the length. So it wants major arc AB, the length of it. So L is going to equal 250 times over 360 times 2 pi 4. Everyone go through and simplify that. 250 because we're asking for the major arc. Everyone go through and simplify that. You are going to need a calculator. A lot of material, right, Trey?
What?
You've been daydreaming.
Yeah, I've been.
It's bad. Don't daydream during chapter 11. A lot, huh? Think about it, we've only technically learned 3 things today. Just feels like a lot, yeah.
I got 0.69444444.
Well, I would do this first. I would get rid of the zeros first.
I did, and then I did the same thing, and then I got the same thing.
Yeah, and then time. So you're gonna go, and then I just go 25 times 8
Why would we times 8?
because it's times right here. Because 2 times 4 is 8. So that's. Hey, hopefully you guys are doing this, so when you get on your homework today, you can figure it out. See. I think so. Yep. Okay, so everyone look at this. When you multiply, I always get rid of the zeros first because it makes it easier. You get to here, right? You get all the way down to here, then you go 25 times 8, which is 200 over 36. And then you can just reduce the fraction. So if you want to, you can go step by step. 100 over 18 pi, 50 over 9 pi. Yeah, but remember, it does. It wants it like that. It's going to want it like that. 25 times 8 is 200. Okay, so listen. It's not going to want a decimal. It's going to want it written like that. Irregular fractions. Okay? 50 over 9 pi. Okay, now look, the pi is just like a variable that's attached to it, right? Just bring it along with it. So, today, I know this is now, like I just told somebody,